this type of questions you are given, you have to make something. Now they give you like in relation the box dimension. They say, okay, the axis, the box should have a dimension where the width is x, the length has to be 2x, and the height h. And you need to find out the area. You need to make sure you use a minimum value of the metal sheet, minimum on the metal sheet, and you need to find this bit. And how are you going to do that one? So let's have a look. The volume of that one has to be fixed. They give the volume, which is 4,000. Now, first one is they want you to find the expression of h in terms of x. To do this one, the first bit, let's call this one as a. So let's do the first one. Okay. If I want to find the volume, it's a cuboid. The volume of the cuboid, if I want to find the volume of the cuboid, is this multiplied by that, multiplied by that. So h times 2x times that one. And that will give me around 2x squared h. And that's volume. But the volume is 4,000. Yeah, so that's the equation I got straight away. So this is my part one. Now the part one says expression of h in terms of x. So I need to make the h the subject. So h is there. I got the 4,000 divided by this 2x is multiplying. Move that on this side. That will divide. So this is my part A. That one done. Okay. Now the next thing it's asking me to do is show area is given by 2x squared plus that bit. Okay. Now to find the area, what I need to do is I need to actually look into, do they want to find the surface area? Do they want you to find out the like the whole surface area of that one? So let me just check. It's an area of metal used. So area of surface area of metal used. So is given by this thing. Now to find that one, because it's a box, the top of the box is open, so it has around 5 sides. So I need to find the area of each and every side. Okay. So if I have a look at the area of, let me do that B here. So let's find the area. If I want to find the area of that bit, this side, the front side, it's going to be this times this. So the area, the total area is going to be 2x multiplied by h. So 2x multiplied by h. And there is a 1 on the back side. So I need to double that one. Multiply by 2. Plus, I need to find the area of this bit. This box here. And there's another one here. So this is x and this is h. So the area of this side will be x, that one, and obviously I need to double it times by 2. Now I need to find the area of the bottom bit. The area of the bottom bit is 2x times by x. So that's my area. Now I need to multiply that one. So that becomes a 4xh plus 2xh plus 2x squared. This is my total area, total surface area of the sheet that's required. Now I got the total surface area. Now I need to make it into this form. Okay. If you look at that one, there is no h in that one. There is no h. So, but here, if I look, there is a h here and h here. So first, I need to simplify it a little bit more. This is 4 and this is 2. So that becomes a 6. I got the area. Now I also know what is h. H is, this is the value for the h. So instead of h, I just replace that value. I put this one, which is 400, no, sorry, 4,000. So I just replace this one. Now let's simplify that one. That cancel, that becomes a 3. So that will become like 12. X squared and that cancel, that becomes a x. So I have the value for the area. So I've just like proved this is the equation for the area. And that's what we need. So there was an x and x squared. So they kind of cancel. Okay. Show the surface area. No, use differentiation to find that part we do now. To find x when a is minimum. So we want to find out a length where we still achieve the 4,000 centimeter cube of the volume, but we use the minimum amount of the metal, sheet metal. So we save money. So let's have a look. So now I have the equation. I'm going to copy the equation. A equals 2x squared plus, okay, over x. Now this over x, I can do something. I can just, rather here, I can call it x to the power minus 1. Law of indices. It was 1. When I move up, it becomes a minus 1. So this is the equation for the area. Now I need to differentiate. So now when I differentiate, I need to differentiate with respect to x. So this side will become a dA over dx. When I differentiate this thing, that becomes a 2 is already here. The 2 comes out, reduce the power by 1. So 2 minus 1 is that. Plus 12,000 is there. Now when I differentiate that one, power comes out, reduce the power by 1, minus 1, minus 1. So minus 1 here will give you minus 2. So get rid of that one, put a minus 2. Now that will become a 4x minus, because that minus 12, 0, 0, 0, x minus 2. That side becomes a dA over the dx. Now the question is, for which a is minima? To find x when a is minima. You know when these are minima or maxima, it is a turning point. And we need to show it is minima. So which means to find it's a minima, we need to make dA over dx 0, which means the 4x minus 12,000 x minus 2 is a 0. Okay, now we need to solve that one. So I got the 4x minus 0. What I can do is I can move this whole thing on the other side. So I got the 4x equals 12. Yeah, I can do that. Now x minus 2 is negative, it goes become positive. X minus 2 can also be written as, because of the law of indices. Now I can move this x square on this side. This x square can come on this side. So that becomes a 4x and times x squared. X and x squared becomes a 4x cubed. Now divide both sides by 4. So you need to divide both sides by 4. So that 4 disappear. Divide this side by 4. So you got x cubed equals to 3. Anyone can you do me the cube of 3,000, please? Cube root of 3,000. Anyone got an answer? 14.4. 14.4. Okay, any more decimal places? 14.42. So 14.42 centimeter. The x value should be that to give you a minimum, but it can be the maxima. I don't know, you know. So we have to prove that for the part D here, find maximum value of that one, show that it is maxima. So that part, oh sorry, that was C, that was D, that was a E. So I need to show if it's a maximum, sorry, minima. To show it is a minima, I need to differentiate that thing again. I need to find out the second differential. So to show it's a minima, do second differential. Which means that becomes a D square A. Sorry, let me write it properly. That becomes a D square A over dx square. When I differentiate the 4x, that will be just a 4. When I differentiate this thing, this is minus 12, 0, 0, 0. When I differentiate that bit, that becomes a minus 3 comes out. Sorry, minus 2 comes out, not 3. Minus 2 comes out and reduce the power by 1, x minus 3. Yeah. So that will become a 4 minus and minus becomes a positive 24, and then 0, 0, 0, 0, 0, 0, and x minus cube. Now what I need to do is I need to put the value of the x here. So now put x equals 14.42. So 4 plus 2, 4, 0, 0, 0, 14.42 minus 3. You don't have to even find the value. It's obvious it's going to be a positive number. If it's a positive number, so it is a positive value. The second differential is a positive, which means if the second differential is positive, which means this is a minima or minimum value of the x that you need. So you can have that, achieve that area of 4,000 centimeter cube. Yeah, so that's how it works. It can be like a cylinder. You can make anything.